Today we're going to talk about transformations and then in particular translations. So a transformation is a rule that causes a change to a figure. The new figure is called the image of the original. So as we are working through today's stuff, you're going to see actually two figures on the graph. The first is going to be what we call the pre-image or the original. And then we're going to do something to it. We're going to move it in such a way, according to this rule, to have a second image, which we call the image. Just a warning, guys, I am going to use two different colors in this video today. So if you want to pause and go get a second color, you are welcome to do that. But let's talk about translations. So in general, transformations is just rules in general, but then there are different types of rules. So there are actually 4 different types of rules. There are translations, reflections, rotations, and dilations. We are only going to talk about 2 of them, and we're going to take a day for each. So today is translations. A translation slides a figure horizontally and I would underline that, it could be both. It could do 2 different slides. So it could go horizontally and or vertically. Every point of the figure moves the same distance and in the same direction. Translations result in congruent polygons, meaning that the figures maintain their size, their same size and shape. We are not going to change the figure itself. We are just moving it on the graph. So with that, let's do some examples. Starting with number 1, let's read the directions. So it says, graph and label each figure and its image under the given translation. Give the coordinates of the image. So here's where I'm going to use the 2 different colors. In the problem, they are giving us the vertices of the pre-image, of the original shape. And so I'm going to go ahead and put those on the graph in black. And then once I move it, I'm going to draw that in orange so that you see the 2 different figures and which one we did first. Otherwise, sometimes it's easy to forget which one we started with. So if we look at this triangle, it says A at -8, 5. So I know each of these is 8, but count it out, -8, up 5, 1, 2, 3, 4, 5. Put a point, they have labeled that A. Then B is at -2, 1 is B. And C is at -3, -4 is C. So I'm going to join these points. Feel free to get out a ruler. If you are not good at drawing straight lines, please do get a ruler so that it is easy to see the shape. And now we're going to translate it. We're going to move it. So I'm going to do the second image in orange. And it says translated 1 unit up and 6 to the right. So each of these, I'm going to move up 1 and over 6. So if I start with A, I'm going to go up 1 to the right 6. So 1, 2, 3, 4, 5, 6. I'm going to point, and now I'm going to label it. Now, I can't just label it A because that's going to add to the confusion of which figure image came first. So there's a way that we show that it is the second. It's part of the image, not the pre-image. And that's by putting this little apostrophe next to the A. You can see that in the blanks to the right as well. So I'm going to label that A with the apostrophe there. If I look at B, I'm going to go up 1 over 6. 1, 2, 3, 4, 5, 6. Label this B with the little apostrophe. And C, again, up 1 over 6. 1, 2, 3, 4, 5, 6. Same thing with that. So then I'm going to join these. And now I'm going to write in the coordinates. So A is at -2 and up 1, 2, 3, 4, 5, 6. B is at +4 and up 2. And C is at +3, -3. Okay, and that's it for that problem. Let's go on to number 2. Actually, sorry, I lied. Let's go on to number 4. I'm going to move this up so you can see number 4. So here is a parallelogram. It's telling us we have vertices at, with E at -6, 6. So I'm going to go -6, 1, 2, 3, 4, 6, and then up 6, 1, 2, 3, 4, 5, 6. Put that there, that is E. For F, it is at -1, 7. That's F. G is at -2, -2. And H is at -7, -3. Hopefully, when you're doing this, you'll be able to see if you miscount, that it'll look a little off, like that's not quite where it's supposed to be. I'm going to draw that in. So now I am going to translate 4 units to the right and 5 units down. So each of these I am going to do, let's see here, 4 units to the right. So let's start with E. 4 units to the right. 1, 2, 3, 4. It's okay that it is still inside that image. It's okay. And now we have to go down. So that's not really where the point is. Sorry, guys. Over 4, down 5. 1, 2, 3, 4, 5. It is still in the figure, in the original figure. That's okay. Don't worry. That's part of why also I'm saying do it in a separate color to make it more obvious. If we go with F, we're going to go over 4, 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. And label that. For H over 4, 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. And for G over 4, 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. And so I will connect these dots. Again, it's okay that the shapes overlap. All right, and we're gonna put in our new coordinates of E, F, G, and H. You could do this as you go along, it's up to you. Just personal preference. E is at, let's see here, -2, 1. F is at 3, 2. H is at -3, -8. And G is at, let's see here, 2, -7. All right, let's go to the back. I am going to skip down to the second set of examples. The top is more of what we were doing on the front. So if we look at the second set of examples, it says determine if the shaded figure is a translation of the white figure. So if yes, describe the translation. So basically, did they take the one that's not shaded and move it, or did they do something else to it? So looking at this, we're going to look at what happened to each point. So this point to this point in number 7 went over 1, 2, 3, 4, over 4, and then it went down 1, 2, 3, 4, 5. Right? Did that happen to every point? So let's do from this point to this point. Did it go over 4? 1, 2, 3, 4. Yep. Over 4. Down 1, 2, 3, 4, 5. That worked. And then last ones. Let's see. 1, 2, 3, 4. Looks good so far. Down. 1, 2, 3, 4, 5. So they did just move it. So this is a yes. And how are we going to explain this? Well, it's going to the left 4. And it is going down 5. Doesn't matter which order you put that in, but you do need to use the words up, down, left, and right. Do not just draw me arrows, okay? You can draw them on the graph, but not in your description. Let's look at number 8. So in number 8, these rectangles are not set the same way. It's not like we just took, it's not like we took a rectangle and just moved it. We had to do something to it, right? But to just pick it up and move it is a translation. As soon as we start twisting it or doing something, it's no longer a translation. So here, because it got turned, right? This is a no. It is not a translation. Number 9, these arrows. Did they just take the arrow, pick it up, and move it somewhere else. Looks like it to me. This is a pretty distinct shape, so it's pretty obvious that that's what they did. And so this is yes. What did they do? We can go from this point to this point. They went over 1, 2, 3, 4, 5, 6, 7. And down 1, 2, 3, 4, 5. So if we explain what's going on, they're going to the right 7 and down 5. Okay. Look at number 10. So here again, this is not just picking it up and moving it, right? It's first the parallelogram started kind of tilted this way, and on the bottom it's tilted the other way. So that starts getting with a rotation. It's actually what we're going to talk about tomorrow, which is it's reflected. It's kind of like a mirror image of itself, but no, it is not a translation. Number 10 or 11, this is a translation. They just picked it up and moved it. And so from one point, notice that I'm using the same point in both figures. Just like we did on the front, we have to, I can't look at how this one moved to down here. It has to be, oh, sorry guys. It has to be these two corners. It can't be how this one moved to down here because those are not the same corner of the figure. So up here, this one went up 2 and over 1, 2, 3, 4, 5, 6, 7. So when I describe that, I'm going to say up 2 and to the right 7. Now I want you to look at number 12. Notice if we were to take this not shaded one and put it on top of the shaded one, they are not the same size. You can also look at the bottom of the shaded one. Covers 1, 2, 3, 4, 5, 6 of these squares, whereas down here this only covers 4. So they have actually messed with the size of the figure. That's called a dilation. We are not going to talk about that this year, but that is a different type of transformation, but not a translation. I know that those are very similar words, so make sure that you're really thinking about what they mean and which one's which. So let's look at our last type of example. We are looking at just one point that's being moved, but they're asking us to describe how it's being moved. So if I'm going from 3 to 7, right? 3 to 7 on the x's, right? So think about a coordinate plane. The first value is x, so I'm going from 3 to 7. That's moving 4 places to the right. Or right 4. Then let's look at what happened in the y. It started with its y value at -1 and it went up to 0. So that's going up 1 unit. So it went to the right 4 and up 1. Let's look at 14. So in 14, again, I'm looking at the x first. It can be useful to kind of draw it a little bit here. So it started at -5 and it's going to -7. So it is actually moving to the left 2. Notice we're always going from the first one here to the one with the apostrophe. That's how we know which direction. for the y values, it started at 6 and it ended at 1. So that's going to go down 5. So this one went left 2, down 5. All right, last one. So again, let's think about where did it start for the x value. It started at -8, which is going to be out here, and it ended at -1, went that direction. So it went 7 spots, right? From -8 to -1, it's moving to the right 7 spots. And for the y, it started at -4 and is going down to -7. So it's going to go down 3 spots. Guys, notice I'm not plotting these points on the graph exactly where it's. I'm not plotting -8, -4, and then plotting -1, -7. You are more than welcome to do that, okay? If you want to draw yourself a coordinate plane here and say, well, it's going from -8, -4, right, to -1, -7, and kind of plot out how many did it go this direction, how many did it go up or down. You are more than welcome to do that. What I was doing is just looking at their places along the x-axis for the first number and along the y-axis for the second number. Either way, here it is moving to the right 7 and down 3. I hope that's helpful, guys. I am going to put a Google form with this assignment. It will probably mark most of your problems wrong, but again, if you watch that little short video I put the other night, I will go through it. I go through every Google form and give you back the points. So do not freak out when it gives you a low score, because it will be fixed, okay? Good luck, guys. Let me know if you have any problems or questions on this assignment, homework number 9.